Hello everybody, this is the last lesson of the sequence unit. If you were in school on Friday, you received it in class ahead of time with the anticipation that we might not have had school today, which was accurate. If you were absent on Friday, then I uploaded the blank copy in the blank folder on Edmodo for sequences. So you can print it right off of there, or you can simply do the questions on loose leaf, up to you. So we're provided with the first term of the sequence, which is 8, and the fourth term, which is 216, and we're asked to find the sum of the first 12 terms of this series. So, there's a long way of doing this question, there's a short way of doing this question, and the long way would be to draw out 12 blanks and try to figure out what all of the 12 terms are, and then take your calculator and add them up. Which, on the day of the Regents is really not an issue because you have 3 hours to take the test. You're not really going to be in a time crunch. But there is another way to do it, and it's involving this formula right here, which is highly recommended. It will really cut down the time you spend on this particular problem. What we are lacking, though, is the common ratio. If we had the common ratio, excuse me, my pencil broke. If we had the common ratio, we could just sort of fill in all of the blanks and again, get the answer that way simply by adding up all the terms. So what we're going to do is use the geometric sequence formula that we reviewed a few lessons ago. Remember, this formula is right in front of you. It's on the formula sheet. All you have to do is know how to use it. And how we're going to use it is how I demonstrated a few lessons ago, and I had called it the cloud method. Basically, we're going to forget about the last 8 terms of the sequence, and we're only going to focus on what is provided to us. So we're given the first term is 8, and 216 is otherwise known as our nth term. And we're going to sub in the 216 and the 8. In for a subscript n and a subscript 1, the first term. The ratio is what we're going to be looking for, so we'll keep it r and n. N is typically the number of terms in your sequence, but it's not going to be 12 here. It's only going to be 1, 2, 3, 4, because again, we're only worried about the first 4 terms of the sequence. So we're going to sub in our n, and we're going to just solve it as normal. So we're going to divide out by 8 on both sides. We're going to get 27, and of course 4 minus 1 is 3. And then we're going to cube root both sides. No plus or minus here because we are not even rooting both sides. If these were 4s, then yes, we would have a plus or minus as our r, but not the case here since 3 is an odd number. So the ratio winds up being 3. So if you take a look at our geometric series formula, now we're going to see S subscript n. S stands for sum, which is exactly what we're trying to do to this above sequence here. So I'm going to change the subscript n to 12 because we're finding the sum of the first 12 terms, and we're just really going to place in all the values accordingly. So the first term is 8. And notice A1 does show up twice. We now know the R value is 3. Our n value now would be 12 because we are finding the sum of all 12 terms. And notice r also shows up in the denominator as well. So it's a really simple formula to use. And then you would just pick up your calculator and definitely use the alpha y equals enter option. So you're going to put in the formula on your calculator exactly as it was on your paper. And there's our answer. Looks like choice 3. Okay, so this formula you can use whenever you're finding the sum of a geometric sequence. This does not apply for any type of sequences. Okay? So there you have it.